¿Qué es la que hay, mi gente? Welcome to eCruz Learning, where it's just that easy. With your favorite host, Master Cruz, and today we're going to learn about how to write a parallel line and a perpendicular equations of the line. So let's get started right away. Example 1 says a line passes through a point 12, comma 5, and it's parallel to the graph of y equals 2/3 x minus 1. Write the equation of a line in slope-intercept form. So for these type of problems and any word problems that you're given, really, I like to solve my word problems in 3 steps. It helps greatly. The first step is list what you want. What is this question asking for? Number 2, list what you know. What is the information that you know? And number 3, the work, meaning put 1 and 2 together. How can you connect them? So let's go with number 1. Number 1, it's usually the last sentence of a problem. So they want you to write the equation of a line. That's what EOL stands for, in slope-intercept form. So this is the equation of a line in slope-intercept form. It's y equals mx plus b. So my final answer, I know that it needs to look like this. What do I know about this problem? Well, I'm going to start highlighting things that I know. If you have an underline and you want to underline them, you can in your notes. So 12, comma 5 is a point. So I know the point. And this is important because we learned, hopefully you know that to be able to write the equation of a line, you need a point and you need a slope, right? So the point here is 12, comma 5. So we have a point. Do we have a slope? Do we have a slope? Well, we do have a slope. It says that it needs to be parallel to the graph of this equation. So the only reason why they give you the equation of the other line, it's so that you could look at the slope, because hopefully you remember that parallel lines have the same slope. So it's important to say for the slope that the slope of line 1, and I'm going to call this M1, equals 2/3. That's the slope of the first line, the line that they gave me. So the equation of a line has to be this, and it has to be parallel, right? So this is also important to know that it needs to be parallel, because the fact that it's parallel, it's going to tell me that the slope of equation 1, which is the one they gave me, has to equal the slope of equation 2, which means the slope that I'm going to use for this problem, okay, the slope that I need to use for this problem is going to be the same. The slope of line 2 is going to be 2/3. So that's what that means. That's what that means. So let's put it together. Okay, let's work together. So what is? Let me write it over here. So we have the work over here. So we have to write the equation of a line, and we're going to have 2 methods to do this. I'm going to show you the first method. It uses the point slope form. So remember, to write the equation of a line, you always need a point and a slope. Here's the point, 12, comma 5, and the slope that we're going to use is 2, comma 3. So let's write it. I'm going to take this, okay, and I'm going to take this, and we're going to plug it into the equation down here. So if I do that, we're going to have the following. On my point, and I'm going to make a little bit of space over here, okay, on my point, what's x and what's y? Well, 12 is x and 5 is y. So if I plug in these in here, I'm going to have the following. I'm going to have that y minus, and y1 is 5. So I'm going to substitute 5 in here, okay, equals, this equals m. We know that it has to be parallel, so we're going to use the same slope, which is 2/3. So I'm going to write down 2/3 over here. And I'm going to open a parentheses. And when I open the parentheses, I'm going to have x minus, and I'm going to write down what x equals, because that's x1. This is 12. So it's important, and I don't know if you noticed, I'm going to call this x1, y1, because that's where we are plotting the points. In point slope form, the points are the y1 and the x1. The x and the y stays alone because that's part of the equation. So this is the equation of a line in point slope form. But originally they said that they wanted, over here, they said that they wanted y equals mx plus b, slope intercept form. So I need to transform this to what slope intercept form, and it's always done the same way. The first step is to distribute this over here. So I'm going to drop the y minus 5. There's nothing different here. Y minus 5 equals, and I'm going to multiply. 2/3 times x is just 2/3 x. And 2/3 times negative 12, well, a positive times a negative is going to be a negative. And then let's multiply this on the side, right? So 2/3 times 12. I'm going to write down the 12 as a fraction. So I'm going to put it over 1. And then I'm going to do, if I say TBT, you say BBB. Top by top. So the top by top here is 24 over bottom by bottom. Okay. And 3 times 1 is just 3. And then when you divide this, 24 divided by 3 is 8. So that means that this number 12 will transform into 8. We're almost done. We're almost done. The only thing that we're missing is that the y is not by itself. And all I have to do is add 5 to both sides of the equal sign. So if I add 5 here to cancel it, I'm also going to add 5 to the 8. Remember to add it to the like term. You should never add 5 to 2/3 x because 2/3 has an x and 5 does not have an x. That will not combine. You have this cancels, that goes to 0. So y equals 2/3 x negative. This will be negative 3. Okay, so that will be negative 3. And that's perfect because that is in the form of y equals mx plus b. And that is my answer. Now, this is not the only way of doing this problem. I'm going to show you a second way. And I've seen that most students or some students gravitate towards the y equals mx plus b so that they don't have to learn a different equation, because this is a different equation in point-slope form, but you could still do it just using the slope-intercept form. We've done a couple of these problems, so hopefully you've done it before, but here we go. This is how you would do it. So you use slope-intercept form, and you're going to have a point, and you're going to have a slope. So from the beginning, I could kind of write the final answer. My final answer will look like y equals my slope, which is 2/3, okay, 2/3 x, and I'm going to have plus b. The issue here is that I don't know the y-intercept. Remember that b is not any random point. B is the y-intercept. B is the y-intercept. So how can I find the y-intercept? Well, the cool thing about this is I know x and y. So I can substitute these into this equation and solve for b. So that's exactly what we're going to do. Let's substitute. Instead of writing y, I'm going to write down 5. So 5 equals 2/3. I'm going to open a parentheses because there's an x right there. And the x value is 12. So I'm just going to write down 12 over here plus b, and I'm going to solve for b. So I'm going to simplify, right? We kind of multiply earlier. We know that you put this over 1, and we did it up here, right? We multiply already 2/3 times 12. So we know that's 8. So I'm just going to come over here and say that 5 equals 8 plus b, okay? And then b is almost by itself, but it's not by itself because it's being added by 8. So I'm going to subtract 8 on both sides. Because 8 is positive, this will cancel. 8 minus 8 is 0. And then you will get different signs, subtract, and keep the sign of the higher number. So this is going to be negative 3 equals b. So I'm going to take this b, which I know that negative 3 equals b, and I'm going to take it and I'm going to plug it in up here. So instead of writing plus b, I'm actually going to erase the plus b, and I'm going to write minus 3. And that is what I was missing. That is the slope of the line in slope-intercept, this equation of a line in slope-intercept form. As you can see, I got exactly the same slope, but this is a little bit cleaner than using point-slope form. However, you'll feel comfortable to use whichever you feel more comfortable with. So we wrote the equation of a line for a parallel, but what about if the question asks for perpendicular? Well, this is still going to be very similar, the same thing. So example 2 says, which line is perpendicular to y equals 1/3 x minus 1 and passes through this point? Well, what do we want? If the question doesn't say any format, we always want y equals mx plus b. We automatically assume that, slope-intercept form. So what do we know in this problem? We know a point, 2, 4. x comma y. And like we said, this is x1, y1. Okay, you can label this x1, y1. And we know a slope, which is 1/3. How did I know this is 1/3? Because when I look at the problem, the only reason, remember, the only reason why they gave you the equation of a line that it's perpendicular to it is so that you can look at the slope. We don't care about the one. We don't care about anything else. We just look at the slope. So the slope here is 1/3. But they also told us that this is perpendicular. So the one thing we know is that perpendicular lines have opposite reciprocal slopes. So they're not the same. And that's the difference between parallel lines. So we're not going to use the same slope, right? We're going to use the opposite reciprocal. So because of that, okay, because of that, then I'm going to write in the work right here that the opposite reciprocal of this, it's going to be, this is positive, so it's going to turn to negative. That makes it opposite. And then the reciprocal, instead of 1/3, we're going to switch them, and you're going to have 3/1. But this simplifies. -3/1 is just -3, because 3 divided by 1 is 3. So I write my point slope form, 1 minus y1 equals m over parentheses x minus x1. And then you substitute, just like we did in the previous problem, the 1/3, you substitute the -3, sorry, because it's perpendicular, -3 for m. You plug in 4 over here and 2 over here. And then you solve, you distribute, you add 4 to both sides, and you get the answer. The last thing that I want to talk about is if you plug in, and this is unrelated to that problem, but it's important that you write it down. If you substitute, okay, this is x1 and y1, this point into a slope in the point slope form, which is y minus y1 equals m over parentheses x minus x1, you have to be careful because the signs are always the opposite. So for example, if I plug in 6, I'm going to get y minus, and then I plug in the 6. And this equals the slope, which we don't have a slope right now, x, but be careful because now this is -5. So there's a minus from the equation, right? There's a minus from the equation, and then there's a negative from the actual number. So you end up with a double negative. These are not the same signs, they're different signs. So this simplifies to y minus 6 equals m over parentheses x plus 5, okay? Plus 5. So you can skip this step if you remember that whatever it's here, it's going to be the opposite in the equation. So when you get -5 for x, on the actual equation is going to say x plus 5. And when you get a positive 6 for y, the actual equation is going to say y minus 6. And why do you ask? Well, the reason for that is because the original equation says minus, and minus means opposite. Another reason for that is because the x always lies. You know what I'm talking about? Like if you had an x, the x always lies. And if you ask your ex, why did you guys break up? The y, it's probably a lie as well. So these two lie. The x lies and the y, it's also a lie. So that means that when you look at the point, you will always use the opposite. I hope that this helps. And for more tips and tricks, please join our Virtual Math Masters community. This was Master Cruz with eCruz Learning, where it's just that easy. And remember, you get your free tutoring session if you join today. Have a great day.